Hello YouTube, it's SWLA Mech 84. I've got my tube set up again. I know it's been a while since my last video, but I think I finally got my boring bar worked out. Thanks to Mr. Matt McGuire on YouTube there, with his feed and depth of cut recommendations for this boring bar, I seem to get a pretty decent finish now, and it'll just have to work for what I'm doing. It doesn't have to be baby butt smooth mirror finish in there. As long as it's dimensionally accurate, then it'll be alright, because I can turn the piece that's going to be going in here to match that thing pretty well, and I can get a nice good air suction fit. Right now my speeds and my feeds are, let's see, I am on C4, so that's 6 2/10 thousandths per revolution. I'm taking 8 thousandths per inch passes. Well, not per inch passes, but 8 thousandths depth cut. That seems to work pretty good. And I'm running at 600 RPM. He had recommended 500 RPM. Well, all I have is 6. That's the closest thing. And I'll show you a couple of cuts here. Get that stuff out of the way there. See if I can get a good focus on it. And that's a pretty good finish. He had said in his comments that he would expect a 125 micron finish, and I do believe that's pretty close to a 125 micron. And that'll do for what I needed to do. No chatter. I have my boring bar extended out over 6 inches. It's kind of hard to see that from there. But I'm using 6 inches of my boring bar. My tube is going to be 12 inches overall, with an inch on each end for threaded connections. So I really only need to bore 6 to 7 inches. And this piece that's in the lathe right now is right at 6 inches. So I can bore through in one pass. I have a nice clean smooth bore. Now when I get in there 3 or 4 inches, I get a lot of buildup. And I don't have a chip breaker on this boring bar, but it does make a lot of buildup, and it starts to push the bar away and chatter. But I just crank in and pull out, clean it off, and start over again and let it feed through, and I don't see any problems with it. It does look pretty good. I have it adjusted on center line, so it's at center height there. And I turn the OD over here with a high-speed tool bit so I can flip it. I had it in the lathe the other way, so I decided that I turned it and I flipped it so that I have a register equal to the bore. If I have to bore something longer, then I can, as long as I turn something on the OD, I'll have a register that's exact to my machine there. And that's about it. It seems to work really good. Thank you, Mr. Matt McGuire. That helped out a lot. And I'll be able to get a lot of use out of this boring bar. I still have to order some more material because I did cut it the wrong way, but this has been a valuable practice piece here, so I know what I can do. And I think I'll be in my next couple of videos probably. He also recommended putting cutting oil on it. I usually run cutting oil on everything anyway, but in my air-conditioned closed-door shop here, it starts to get pretty smoky, and that's not good stuff to breathe. So I'm going to probably be installing a little suction system here on the lathe, probably mounted on the wall right here somewhere, and piped outside with some kind of blower or whatever. I'm going to take a little trip to Lowe's there after a while and see what I can come up with. And I'll probably take some pictures and show that with a little switch over here so I can flip it on and get some of this smoke out of my face. But I'm going to get some more material coming, and I'll actually get started on my real tube. But next what I'm going to do, I'm going to go ahead and cut these threaded connections on here. Let me get you turned around here. Okay, I know in my previous videos I had put up a little drawing here, like so, of what I'm going to actually do with this tube. And I'm going to go ahead and do some of that now, just to practice. Really, I'm not going to use this tube for anything else, just to get used to cutting the material, because it is so cheap. Yeah, that DOM tube, I mean, it was only like, it was somewhere around $20 for a little over a foot of that stuff, compared to, you know, $80 for a piece of stainless round, or even alloy round that I'm gonna have to drill out, and oh, it's just miserable. And that's a nice thick wall to get all the turning room that I need in there. So do a little bit of that here. Go ahead and turn my bit here. Not cutting with the right side of my bit. Go ahead and flush it up. I've already faced this off. Okay, set my 0. Got me a new 6-inch scale in just a while ago when the mail passed there. I got hundredths on there. Alright. Get my guesstimators out, like Mr. Keith calls them. Need to turn this OD down to 2.263. Right now, we're at 2.474. You can take 211 thousandths off of that, which is 105 thousandths per side. So I'll probably take it in 20 thousandth intervals here. Actually, I'm going to take it in 10 thousandths because I don't want to burn my high-speed steel. So it's going to take a little while, but I'll speed the video up for that. Alright, that was 94 thousandths there. And these chips right here, they're coming off just like Mr. Matt McGuire said on YouTube on my comment there. They're straw colored until the very last end of it, then they turn blue. You won't be able to see that probably, but it is very straw colored, and had a couple of blue ones there. at 20 thousandths is too much of a cut. I think he had recommended 8 thousandths to 16 thousandths, and a 10 thousandths cut seems to do really well. And it's actually a decent surface finish on that. Let's see if I can get in a little better here to show you the surface finish on that. Let me see. Really pleased with that. I think it'll work just fine. Yeah, here's a pretty good surface finish right there. I like it. It's good. All right, let's see. That was 94 thousandths. And I'm not sure if this bit is exactly on center line. Up or down, that'll make a difference on my dial. So my guesstimators, or my RCBS dial calipers, except they're digital, says 2.383. We need a 2.263. So, that's not right. Let's measure that again. 2.383. I need 2.263. 2.383. Okay. So I still need to take 60 thousandths here. Okay. Get after it. Check it again. .355. Okay, that was 40. 2.314. 25. And clearly my bit's not on center line because it's not tracking with my dials. I'm pretty sure I put it a little bit below center line. So I'm at 295. Okay. I took 10 off of that with my dials. Oh, that took 10 off there. Okay. Well, it's doing good then. Alright. 2.267. I want a 2.263. So I got 4 thousandths. Dial in 4, cut it off. 2.263. There's my OD that I want. Now that OD needs to go in 490 thousandths, and I'm well over that. There's 490 or so right there. So I'm good with that. And then I need to go 302 thousandths. 302 thousandths at 2.25 diameter. So right now I'm at 2.263. So I need to take 6 thousandths to get there. Need to put a mark on here. Use my garage sale calipers to take care of that. I am going to order some Dicam if Mr. Donald Cossett is watching. We come in 302 thousandths. 302. Now, if I was actually making my part, I would set up a dial on my longitudinal feed so that I would know exactly where I'm going. I really just want to practice the threading on this material, so I'm just going to eyeball this in here. I'm going to go ahead and put my 490 thousandths mark. Okay, let me get a Sharpie. Wipe this off. Put my 490 thousandths mark. I'm going to put my 302 thousandths mark. Now I need to come down to 2.25 to the 302 thousandths mark, taking 6 thousandths. I got a lot hanging out there. I got probably 4 inches hanging out, so I get a lot of spring in my cut. That's why I keep going back and forth over and over again, just so that it'll clean up and actually be at a good OD. Let's check this. That's 2.257, so I need to take another 7 thousandths off. 2.250. Now I'm going to color that back in. I have some grooves to make in here. Okay, I need to put a thread relief, and it starts at 242. It starts at 242 and it ends at 302. Now I'm going to switch my bits over. Okay, so I'm going to put in one of my threading bits. I make thread reliefs with the threading bits pretty often. Okay. And get this lined up on center line. Right now we're a little under because it's pitching back towards me. Still under. Still a little bit under. Okay, getting there. Okay, that just tipped the other direction. Now it's leaning back towards the part on the top. The top of it's leaning back towards the part. So I just hit the breakover point there. Alright, and that's vertical. I know you can't really tell there, but you know, get my 25 thousandths depth per side. So with my double dials on this lathe, I need to put 50 thousandths per side on my dial to get a 25 thousandths per side depth. Okay, there's my thread relief. Get in for a better shot there. Whew. Okay. Alright, and then I'll have to come pick this up in a second. Timer went off on dinner. I need to go cut some vegetables up and get the beef stew finished up. Be back in a minute. Alright, got that taken care of. Now I'm going to go ahead and set my machine up to thread 24 threads per inch. I'm going to put a 2 1/4 24 thread per inch male thread on the end of that pipe. And then I'll flip it around. Well, I'll put the other piece in and cut a female thread in. Usually I like to cut the female thread first to the full thread depth and then cut the male thread. That way I can have the female thread to check it, because I find it easier to take a little more off the male thread, especially if I've taken it out of the machine. I can put it back in, I can jump back in the thread pretty easily. Where the internal thread, it's always just a pain having to look in the hole. I like to cut that once and then I cut the male thread to fit it. But in this case, since I'm just want to get a feel for the material, just to make sure that I don't have any other special requirements before I really start on the piece, I'm just going to go ahead and cut the male thread down to the double thread depth that is called for on the fish tape, which is, okay, let me find my fish tape here. Here we go. The double thread depth for 24 threads per inch is 54 thousandths. So that's a 22 thousandths depth per side. And I'm going to set up the dashboard dial just because I like to know how far I'm actually traversing in. To be able to match those numbers there, you have to have the dashboard dial for the direct in feed to be able to measure, because I am going to turn the compound to the 29.5 degree, so I will be basically sliding alongside this thread whenever I go in, so it will be a fraction off, and I just want to make sure that I'm exactly there just for practice. But I'm going to get this set up for 24 threads per inch. First thing I have to do is get my feed set to the lead screw instead of just the regular feed. And 24 is C6. I'm already in C. So 1, 2, 3, 4, 5, 6. Make sure. 1, 2, 3, 4, 5, 6. Alright. All my feeds and everything are okay. I'm going to switch to 70 RPM, which is B1. That's my lowest speed that I can possibly go. And that'll be better for this big stuff. There's a lot of feet per minute on that bit there, and I'm going to take really light cuts because I actually want a decent finish without having to file it or sand it a whole lot. Alright, well, I'm going to move this here and I'm going to get my compound set up. Okay. There we go. Back this down. Grab my wrench. Grab the wrong wrench. Okay. Still grab the wrong wrench. Oh, it's been too long since I've been out here. Okay. Finally. Get my can so I don't spill everything. Okay. And I know on my mark here that it corresponds to 60, but I'm going to go ahead and check it with my little angle gauge. So I'm going to set it for 29.5. I'm going to lock that down. That's my 29.5 degree. Okay. Get this resituated again. All right. Now I'm going to bust this loose. Get this threading bit nice and flush here. Okay. I don't see any light between anything. Finger tight that. Back out. Tighten it up. Check it again. Alright, looks good. Actually, instead of setting up my dashboard out, I'm just going to get a thread gauge here. Just like that. I'm going to find 24 on it, and I'm just going to use that to gauge it. I don't have it. All my indicators are being purposed for something else right now. Sounds like a really big bird just landed on the roof of my shop. Sorry about that. Kind of distracted me a little bit. Okay. So. See if we can get a close-up shot here. Okay. And on 24 threads per inch, I can go on any number on my thread dial here. Need to tighten that up. One through 8. Okay, and then we're ready to go. I'm going to come in and find 0, set all my dials at 0, and get cutting. Zero, 24 threads per inch. Yeah, it looks pretty good. And I'm just going to take a whole bunch of cuts until I get down to my thread depth. Looks pretty good. I'm going to chamfer this leading edge a little bit. Okay. Okay, and then I'm going to come back in and I'm going to catch that thread again. Okay, that's 0. There's my thread. It's a little rough on the outside there. This material is just not wonderful for finishes, but if it'll work, it'll work. Let's see, get my file. Alright, I'm going to take my feeds off here. Run a little bit faster. File that off. Alright. Okay, I'm going to clean up the back of it there. As you can see here, that inside finish using those recommendations on there, and the outside finish with the high-speed steel with that same feed rate and cut depth came out pretty good. The inside finish with the boring bar, like I said, it's not perfect, but man, it'll do. It was a lot better than I was getting. And I'm going to be putting aluminum baffles in some of this, so as long as I can get a good location in there so that I'm not moving around, I'll be able to get a tight fit on that board. There's no problem with that. Here you can see the threads here. But I'll have another piece, a female, that's going to slip over this so that I can cut, so that I'll have 2 individual pieces of smaller length that I can deal with. This shoulder right here, I just wasn't worried about it. I just turned off enough to get to where I needed to go. But that's it. So next video, I'll probably see if I have the right dimensions on this end and put some internal threads. I'm going to try to thread upside down and out with my threading tool. Let's see if it'll let me do that. But that's it for now. Thanks for watching.